Hello, in this video we're going to be talking about average rate of change. The average rate of change between 2 points is the slope between the points. So let me just draw a quick example here. If I have a function that does, anything, it can be squiggly and wiggly. If I want to know the average rate of change between this point and this point, all we need to know is the slope of the line that goes through the points. So the reason this works is because our function is obviously changing quite a bit in between these points. It's going down and then back up and then down and then back up. Well, the average of all of those downs and ups will be this line right here. That's our average rate of change over that whole span. So we only care about the slope between those 2 points. So if we call this point, let's say call this point x1, comma y1, and we call this point x2, comma y2, the slope between 2 points is just y2 minus y1 over x2 minus x1. Or another way to think of that is rise over run. If we are looking at a graph, usually rise over run is probably the easiest way to find the average rate of change. But if you're not looking at a graph, if instead you're looking at a function, you might have to use this formulation instead, where you actually will be given 2 points to plug in for x, and you have to use those to plug them in for y. So this is still y2 minus y1 over x2 minus x1. We're just using a's and b's and f of a's and f of b's to indicate y2, y1, x2, x1 instead. So this is a formulation that you might want to commit to memory because it might show up on an exam. So let's do some examples. In question 6 from the Homework 10A Common version, we are asked to find the average rate of change for the secant line AB. So it's important to note that the secant line AB is just this line here. We can ignore everything else. We just need to find the slope between this point and this point. Well, if we call B, we can call that x2, comma y2, and we can call A x1, comma y1. I always label these in reverse order. Then all we're really doing is finding the slope. So our M, our slope, or our average rate of change, will be y2 minus y1 over x2 minus x1, which is, let's see, this is the point negative 2, comma 2, and this is the point negative 1, 2, 3, 4, 5, comma negative 1. So our y2 is 2 minus our y1 is negative 1 over x2, which is negative 2, minus x1, which is negative 5. Okay, a lot of negatives in here, but we can simplify this. 2 plus 1 over negative 2 plus 5 becomes 3 over positive 3, which is just 1. So our average rate of change is 1. And there was another way we could have done this. You can, since we actually have a graph we can look at, we could just find our rise over run, which is positive 3 over positive 3. Remember, we always go in from left to right, so it would be positive 3 over positive 3, which again simplifies to 1. So a couple different ways to think about this problem. We're just looking for slope. Notice you can completely ignore all of this information and all of this other graphic information on the image as well. So all we cared about was the slope between those 2 points. So our average rate of change is 1. For question number 12, we're given a very similar problem. We can ignore all of the information about this circle. If they were to give us any formula for the circle, we could ignore that too. The question they're asking is, what is the average rate of change for the line that's tangent to this circle? And they actually drew the line on the graph for us, so all we have to do is look at the line. So to find the slope, we need to identify 2 points. They only gave us 1 point to start with, so we're going to have to find another one on our own. So here's our first point. Let's pick, I don't know, how about this point? This looks like it crosses right through a direct intersection, so that should make it easy. So to find the average rate of change, we're looking for our slope, which is y2 minus y1 over x2 minus x1. We'll call this x1, y1, and we'll call this x2, y2. And this first point, I can identify it as 1, 2, 3, 4, 5, negative 1. And the second point was 5, 6, 7, negative 4. So let's plug these in. We get y2 is negative 4 minus y1 is negative 1 over x2, which is 7, minus x1, which is 5. So we end up with negative 4 plus 1 over 7 minus 5. That simplifies to negative 3 over 2. So our average rate of change is negative 3/2. Then the question they're asking us after this is find the equation of the tangent line and write it in slope-intercept form. So we're finding the equation of a line. Given the information we have, we know the slope of the line, and we know a point from the line, that point A that was given to us. You can find the equation of a line using the point slope formula, which looks like this. Y minus y1 equals m times the quantity x minus x1. So we know what y1 is. That was negative 1. We know what m is. That's negative 3/2. And we know what x1 is. That was 5. So we can plug all 3 of those pieces of information in, and now all that's left to do is simplify it because they want us to write this in slope-intercept form. That means get y by itself on the left, so that our equation is in the form y equals mx plus b. So coming back up to what we have here, we're going to simplify this a little bit. The y minus negative 1 becomes positive 1. And then I'm going to multiply the negative 3 over 2 through the parentheses. That'll give me negative 3/2 x plus 15 over 2. And then I need to subtract 1 from both sides to get that y by itself. So we end up with y equals negative 3/2 x plus 13 over 2. And that is our answer that goes right in this box. Negative 3/2 x plus 13 over 2. Question number 14 is asking us to find very similar information, but they're giving us very different information. Our last 2 questions had visual graphs we could use to find the slope using, say, rise over run or finding 2 points. But in this example, we have a formula. So I'm going to scroll back up for a second and remind us of this formula here I put in a box. The average rate of change between these 2 points is still going to be y2, that's y2, minus y1 over x2 minus x1. We're just going to have to do a few extra steps to figure out what our y values are. They won't just be given to us in a picture, we'll have to actually calculate them. So I'm going to write as my first step, we've got, this should say f of t, I think they made a little mistake there. So f of t equals t cubed plus 4t squared plus 3, And we want to find the average rate of change from t equals -3 to t equals 2. Well, this is our A, and this is our B. So what we would do here is we would plug it into f of b minus f of a all over b minus a, which will be f of 2 minus f of -3 all over 2 minus -3. So we're going to actually have to figure out what f of 2 is. We'll just kind of do that off to the side. F of 2 is 2 cubed plus 4 times 2 squared plus 3, which is 8 plus 16 plus 3, 24, 27. So I end up with 27 as my f of 2. Now we're going to do the same thing for f of -3. F of -3 would be -3 cubed plus 4 times -3 squared plus 3. And as we simplify, -3 times -3 times -3, that'll give us -27. And then -3 squared will give us +9 times 4 is plus 36. And add these all together, we get, what is that, 9 times 12, I think. All right, so we get 27 minus 12 over 2 plus 3. 27 minus 12 is 15. 2 plus 3 is 5. So we end up with 3. Our average rate of change was 3. Another way to solve a problem like this is you could literally graph this if you wanted to. You could figure out what the points are at -3 and 2. You could figure out what the y values are by just looking at the graph. So our points, let's see if we can actually draw this. So this graph's going to be big. One of our points would be 2, 27. So let's say these are 5, 10, 15, 20, 25, 30. So 2, 27 would be like here. And -3, 12 would be 5, 10, about here. So regardless of what our function is doing in between these points, who knows? Maybe our function is going like this in between the points. We don't care. All we're looking for is the slope between these two lines. And we can find that using rise over run, for instance. So there are multiple ways of solving these problems, but what we just did was the algebraic method. So that should be all you need to know to do the homework problems on homework 10 related to average rate of change. Good luck!